All right, today we're going to cover 3-2, using algebraic methods to solve systems of linear equations. Our learning targets: solve systems of equations by substitution and solve systems of equations by elimination. This should be review. You should have practiced this in Algebra 1. And do remember to take notes and do the check it out problems. All right, and so in substitution, you solve one equation for one variable and then substitute the expression into the second equation. So we used graphs yesterday. Today, these are algebraic methods. The first one is substitution. Let's look at the first sample problem. Use substitution to solve the system of equations. So this one is pretty easy. You already have one equation or one variable solved in terms of the other. So y is equal to x minus 1. So we're going to take this expression and plug it in for y here, and then we're down to one equation with one variable. So as I said, this is the second equation. I plugged x minus 1 in for y, and now it becomes a simple algebraic expression. We combine our like terms, solve for x, and we get x is equal to 4. So we have one of our variables solved. We need to solve for the second variable. How are we going to do that? Well, we know that y is equal to x minus 1. We already saw in the last slide that x is equal to 4, so we plug 4 in for x and find our y. And our solution, it's an ordered pair, 4, 3. Second example is a little bit trickier. We want to solve by substitution, but we don't have a variable in terms of another one. The easiest one to do would be to subtract 2y here and have x in terms of y. But they actually show you isolating x or isolating y. You can do either. It's always best to choose the easiest one, but it's up to you which variable you want to isolate. So here they have you isolating y, and here they have you isolating x. To isolate y, we're going to subtract x from both sides and divide by 2. And that gives us y is equal to negative 1/2 x plus 2. As I said up here, to isolate for x, I just subtract negative 2y from both sides, and I have x is equal to 4 minus 2y. And now I'm going to take my second equation and plug in my substituted variable. So in this case, I'm going to plug this in for y. In this case, in the second method, I'm going to plug this in for x. Here, of course, you get fractions, which I know some of you don't like. So we're going to distribute our negative 4 across these two variables. We're going to distribute our 3 here. And we get 3x plus 2x minus 8 equals 7. Here we get 12 minus 6y minus 4y equals 7. Combine our like terms, and then eventually solve. And we get x equals 3 here, y equals 1/2. So you're not probably going to do both of these. You're probably going to choose method 1 or method 2. Once you find your first variable, you're going to then substitute that into to find your second variable. So for method 1, we found what x was. We're going to plug x equal 3 into our equation. So we get 2y is equal to 3 plus 4. Subtract our 3. Divide the 2, and you get y equals 1/2, which is what you found over here from method 2. So to find our x, we would plug 1/2 in for x, and I'm sorry, my PowerPoint did not. It's going to be 1 plus 1/2 is equal to 4. The PowerPoint kind of messed up the 1/2 and the 1. And let me just redo this. So you're going to get, I'm not sure what they did there actually. So you should have gotten, where's our equation here? Let's go back here. So in method 2, we have, we're actually trying to find x. So x is equal to 4 minus 2y. We found that y is 1/2, so 4 is equal to Whoops, sorry. X is equal to 4 minus 2 times 1/2, which is just, this is 1, so X becomes 3. So sorry about the PowerPoint, didn't import very well. All right, you're going to do this check it out problem and this one on substitution. And now we'll move on to elimination. So elimination, you get rid of one of the variables by adding or subtracting equations. So you may have to multiply one or both equations. What you want to get is you want to get the same number or same coefficient in front of one of the variables so you can eliminate it. So let's look at an example of that. Use elimination to solve the system of equations. Here's our system. This one is fortunately about as easy as you can get for elimination. You have the same number in front of your y, and better yet, they're actually opposite signs, which is ideal because then we're able to add the equations as opposed to subtracting. And I see when students subtract equations, things get sometimes messed up because they forget to distribute the subtraction to all the terms. So here it's just a matter of adding the two equations. 3x plus 4x is 7x. The 2y and negative 2y cancel out. 4 and negative 18 is negative 14. And now we just divide by 7. X is equal to 2. And whoops, negative 2. I'm glad they kept me honest here. And now again, how do we find y? Well, we're going to substitute it into one of the equations. It doesn't matter which one. If I pick the first one, 3 times negative 2 plus 2y equals 4. This is negative 6 plus 2y equals 4. Add the 6 to both sides, 2y equals 10. Whoop. Or y is equal to 5. So our solution is negative 2, 5. So that one's pretty simple. Obviously, they're going to be more complicated than that. So as our next example is, so here's the next example. Neither x nor y have the same number, so we're going to choose either x or y and make the number the same for both equations. The easiest one to choose is probably the smallest, greatest common denominator or factor. In this case, if the greatest common factor is probably going to be 6, because if I multiply this by 3 and multiply this by 2, these are going to each be 6. When you multiply, a couple things to remember. You have to multiply the whole equation, so every term in the equation gets multiplied. Secondly, it's nice to multiply it so that the signs of the top and bottom are different. Then you can add instead of subtracting. So what I'm going to do is I'm going to multiply this equation by 2, and I'm going to multiply this by negative 3. That way I'm going to have a positive 6 here and a negative 6 here, and I can add the two equations. So here we see them multiplying top equation by 2. So that gives me 6x plus 10y equals negative 32. Multiply this by negative 3 to get negative 6x minus 9y equals 27. And now I add the two together. And this cancels out. 10 minus 9 is y. Negative 32 plus positive 27 is negative 5. So that made it pretty simple. Now substitute one of them in, or substitute this into one of my equations. So if I pick the first one, 3x plus 5 times negative 5 equals negative 16. I end up getting 3x minus 25 equals a negative 16. Add 25 to both sides. Whoops. Plus 25 plus 25. 3x is equal to 9. X is equal to 3. And my solution is going to be 3, negative 5. Okay, so those are the two types of elimination examples. You will do 2. This first one. And here's our second one. So the last thing we need to know about substitution and elimination is that we can also classify systems without the graphs like we did last time, but just using the solutions to our substitution or elimination problems. So remember, An identity such as 0 equals 0 is always true and indicates an infinite number of solutions. So from yesterday, if we have an infinite number of solutions, that means it's basically the two are the same line, and it's going to be consistent and dependent. So an identity will be consistent and dependent. A contradiction will give you a solution that's not true, like 1 equals 3. It's never true and indicates no solution. So remember, for this one, this is an example of parallel lines, and so it's going to be inconsistent. So else, it's going to be two separate lines, which means it's going to be consistent, meaning it has at least one solution, and independent. So you're either going to get a solution or you're going to get an identity or a contradiction. So let's look at an example. Oops. Classify the system and determine the number of solutions. All right, so here's our system of equations. What do we want to do first? Well, first we want to try and see if there's a solution. So since isolating y is straightforward, we're going to use substitution. You could have used elimination. So they subtract 3x and we get y is equal to 1 minus 3x. We substitute that in. So 2y plus 6x is equal to negative 18. So we're substituting it in to try and solve for x. Distribute. And you can probably already see what's going to happen. Our negative 6x and positive 6x cancel out. And we end up, even before we solve for one variable, getting a contradiction because 2 does not equal 18. Because it's a contradiction, we know there are no solutions, meaning it's parallel lines. And therefore, you would classify this as inconsistent, number of solutions, no solutions. All right, we are going to wrap it up. You're going to classify this system of equations and determine the number of solutions. Remember, you want to try and solve first using substitution or elimination, and then classify and find solutions. And if you do get a solution, then it's going to be consistent and independent. So that wraps up this section. Please make sure you get your notes and write down any questions, and I will see you next time.